Okay, this is Physics 202 exam for spring 2012. This should say 202. Which of these equations is correct? Alright, so just want to go through each equation. Although in this case it's the first one. We have 14 minus 4i1, so starting here, positive 14 minus 4i1, that's correct because I'm going with the current. And then plus 6 equals 0, so A is the answer. What does the circuit breaker do? Alright, it turns off if the current exceeds a certain amount, so that's A. It does not turn off if the input current exceeds the output current, that's a GFCI. It does not provide an alternate ground, and it does not create a parallel circuit in your house. What value is constant for all household devices? That would be voltage, so A. Devices in a house have different powers, they have different currents, and they also have a different amount of charge going through them. So the only thing that's constant is the voltage. Circuit breaker, you have a 1200 watt heater and a 720 watt fan. You add a 240 watt blender. Circuit breaker turns off. They all operate at 120 volts. I can calculate the current for each. It's just power over voltage. So 1200 over 120 is 10 amps. 720 over 120 is 6 amps. And this is 2 amps. So it operates just fine at 16 amps. But when I add the extra 2 amps, somewhere between 16 and 18 is when the circuit breaker kicks off. So that is D, 17 amps, which is the only number between 16 and 18. Here I have 3 wires going in. I have 8, 4, and 2 amps. 8 plus 4 plus 2 is 14. So the current that is coming out here is 14 amps. Has nowhere else to go. I have this resistor when I close this switch, so it's like that. What happens to the voltage or potential across R1 when I close that switch? Excuse me. I close that switch, this resistance goes down. That is the resistance of this branch, and so the voltage also goes down. That means that the voltage over here has to go up, so it increases. So number 6 is B. In a circuit with resistors in parallel, what happens to the equivalent resistance? As you add more resistors in parallel, the resistance decreases, so number 7 is B. How are natural magnets created? They don't mix with magnetic particles. It just doesn't really make sense. Ferromagnetic materials undergo very high pressure and temperature. That might be true, but not necessarily. Fossilized dinosaurs are magnetic. Nah, that's not even true at all. So it's D. Molten metal solidifies in the presence of a magnetic field. So it's D. Which of these statements is true? Magnetic monopoles do not exist. That's true. Opposite poles of a magnet attract. That's true. All permanent magnets are ferromagnetic. That's true. So it's D. Number 9 is D. The Earth's magnetic field plays a role in which of these atmospheric phenomena? It would be aurora borealis. That's C. Negatively charged particle enters magnetic field as shown. What is the force acting on the particle? Let your fingers go in the direction of V. They fold towards B, and so that gives you a force that's up. However, it's a negative particle, so the force is actually down. So that's C. Pass a wire through a magnetic field as shown. What is the direction of the wire? The current in the wire. So my V is down, my magnetic field is out of the page, and I want to know the direction of the current. So I let my fingers, actually I want to know more specifically what is the direction of the force on the charges in the wire, and then that'll give me the direction of the current. So V is into the page, is down, B is out of the page. That gives me a force that's to the left. Let fingers go in the direction of V. They fold towards B, and your thumb points to the left. That means that the current is going to go to the left. That is A. Current travels through a wire as shown. What is the direction of the force on the wire? I is up. Let your fingers go in the direction of I. They fold towards B. It's going to be to the left. C. Alright, a coil of copper wire is rotated by an axis as shown. There's a current going through it as shown. What is the initial direction of rotation for the coil? Alright, so my I'll just take this side right here. My current is out of the page, like that. My magnetic field is to the right. What is the direction of the force on that wire? That is going to be up. So my force is up. So on this side, my force is up. On this side, my force is down. That's going to cause for a clockwise rotation. What is the charge of this particle as it travels through this magnetic field? Just first imagine that the charge is positive, and then ask yourself, what is the direction of the force? So if I have a particle traveling in this direction with this velocity in a magnetic field like this, that particle is going to feel a force that is downward. Alright? That would be for a positive particle. That means that this particle must be negative because it feels an upward force. So 15 is A. Okay, so what are the currents in each of the branches of the circuit? First you want to just choose directions for the currents. Now I've labeled them, but I still need to choose directions. I'm going to choose I1 to go in that direction. I'll choose I2 to go in that direction, and I3 to go in that direction. It doesn't matter the direction that you choose. Alright, I just chose that sort of randomly. Then I want to choose the equations, write the equations. Let's see, I'll start with the loop. For the upper loop, if I start right here and go in that direction with the current, I get 14 minus 4I1 plus 10 plus 6I2. That's equal to 0. And then if I take the bottom loop, let's start here and go opposing the current, and I get 10 plus 6I2 minus 6 equals 0. And then I can also do the loop, or the junction rule rather. I'll just pick a junction there. The incoming currents are I1 and I2, and the outgoing current is I3. So those are my three equations. It's fairly simple to solve because the second equation only has I2 in it. So I'll just go ahead and solve for I2. I2 is going to equal negative 4 over 6. That's negative 2/3 amps. So that means that I2 is going to be 2/3 amps to the right. To the right because I chose it to the left, but it came out negative, so that means I chose it in the wrong direction. Alright, so now that I know I2, I can take equation 1 and solve for I1. So I get 14 minus 4I1 plus 10 plus 6 times negative 2/3 equals 0. So let's see, this is negative 4I1 plus 24 minus 4 equals 0. So I1 equals negative 20 over negative 4 is equal to 5 amps. So 5 amps is I1. It comes out positive, so it's also to the right, or it goes counterclockwise as well because it goes up in this direction like that, and counterclockwise. I took either to the right or counterclockwise. So 5 amps. And now I just want to find I3. Well, I3 equals I1 plus I2. That's 5 minus 2/3. Right, because that's I2. Remember, you keep the negative. 5 minus 2/3, let's see, that's 15/3, so it's 13/3. 13/3. And that's to the right. Or, what's this? Counterclockwise. Some of you didn't put the directions, I'll just count off a few points for that. Alright, so for this one, you first want to find the equivalent resistance. This 1 and this 2 combine to give me a 3 ohm resistor, and then the 6, 3, and 2 combine to give me 1 over 1 over 6 plus 1 over 3 plus 1 over 2. That's equal to 1 ohm. So this whole thing is 1 ohm. So that means that my equivalent resistance, REQ, is equal to 4 plus 1. That's equal to 5 ohms. Alright, so I can find this current is going to equal 10 over 5, which is 2 amps. So that current, which is the total current going through the circuit, is also the current going through R1, so it's 2 amps. And then V1 is just going to be 2 times 4, the current 2 amps times 4 ohms, That's 8 volts. Now, if I have 8 volts here, that means that across this whole parallel branch, I must have 10 minus 8, or 2 volts. So my total's 10. If I have 8 here, I have to have 2 here. Alright, so that means that V2 and V5, V2 is 2 volts, V5 is also 2 volts. Alright, I can go ahead and calculate the currents. I is just V over R. So here I5 is V over R, 2 over 2, which is 1 amp. So I have 1 amp here. And then I2 in a similar way is 2 over 6, which is 1/3 amp. Alright, now, I know that I have 2 amps of current coming in here. There are a variety of ways you can do this, but I know I have 2 amps of current. Alright, I have 1/3 amp here, and I have 1 amp here. That means that I have to have 2/3 amp here. 2/3 amp, because 1 plus 2/3 plus 1/3 equals 2 amps. Okay, so that means that I3 and I4 are both 2/3 amps. And then I just solve for V3 and V4, I times R. 2/3 amps times 1 ohm is V3, so that's 2/3 volts. And 2/3 amps times 2 ohms is 4/3 amps. Excuse me, 4/3 volts. Notice that 2/3 plus 4/3 equals 6/3, which is 2. So I also have 2 volts across this branch, which I know to be true. There are other ways that you can do this. If you have questions about it, come see me. See, a particle is carrying a -3 coulomb charge, moving with a velocity as shown through a uniform magnetic field. What is the force in vector notation? Right here, all you have to do is do the cross product. S is equal, or F is Q times V cross B. That's -3 coulombs times V, which is 2J minus 1K, crossed with 4I plus 3J. Alright, so -3, and then you do FOIL, first, outer, inner, last. Or there's another way you can do this where you set it up in a matrix, and I think one of you did it that way that you learned in Calc 3. Alright, so just do the FOIL method. So I have 2 times 4 is 8, J cross I. 2 times 3 is 6, but that's J cross J, so that's 0. J cross J is 0, so I'll leave that out. -1 times 4 is -4, K cross I. And then last, -1 times 3, K cross J. Okay. Then I also want to find out what are these cross products. This is I, J, K. I have to use the right hand rule. J cross I. My fingers go in the direction of J. They fold towards I. That gives me -K. My direction is my thumb is in the direction of -Z or -K direction. K cross I is equal to positive J. Fingers in the direction of K. Fold towards I, your thumb points in the positive Y, and then K cross J equals -I. Alright, so with that, I can do this. I have -3 times 8, that's -24, times -K, that's 24K, positive 24, the negatives cancel. 3 times 4 is 12, that's positive 12, times K cross I, which is J, so that's plus 12J. -3 times -3 is positive 9. K cross J is -I, so it's -9I. That's in newtons. That's the force on the particle. Alright, find the radius circular path. Electron moving at 32 kilometers per second in a plane perpendicular to a 3.2 Tesla magnetic field. Alright, B is 3.2. V is 32 kilometers per second, which is 32,000 meters per second in SI units. Q, it's an electron, so Q is negative 1.6 times 10 to the minus 19 coulombs. And then M is 9.11 10 to the minus 31 kilograms. I know that my electrical force, QVB, is equal to my centripetal force, that's mv squared over r. So I solve for r. One of my v's goes away. R is mv over qb. Just plugging in these numbers, I get 5.7. Pretty simple problem, just plug it in. Really, the most common mistake was to not do this, not convert 32 kilometers per second to meters per second. Alright, a wire of negligible resistance fit into a rectangle is in this figure. I want to know what is the magnetic field has a magnitude equal to 2 Tesla. It's pointing to the right as shown. Know the magnitude and direction of the force. That will F is equal to I LB times the sine of theta, but here theta is 90 degrees because the current is flowing in that direction and the magnetic field is pointing to the right. So I solve for the force. First I need to find I, but I is equal to V over R times L times B. V is 10 volts, R is 5 ohms, L is 0.1 meters. That's my 10 centimeters in SI units, and then B is 2 Tesla. Let's see, so that's 2 times 2 times 4 is 0.4 newtons. So that's the magnitude, and then you have to use the right-hand rule to find the direction. Let your fingers go in the direction of V. They fold towards B. The force acting on this wire is out of the page. You could have also just written the symbol like that, or you could have said that it is in the plus K direction, or the positive Z direction. Choice.